Hello, hello everybody. In this video, we are going to do a couple of examples for two-sided or two-tailed hypothesis tests. This is the last video in this section. Congratulations. Once you get to the end of this video, you've made it through the longest section in this unit. So there are two examples here in your notes. There's one on page 19. I'm actually going to start with the one on page 20, and then I'm going to have y'all go back and try the one on page 19. Okay, so I'm going to use this one that starts with the National Institute for Occupational Health and Safety. Okay, so let's go ahead and jump right into it here. Okay, so in this scenario, we're talking about job stress, right? And they have a news report that claims that 75% of restaurant employees feel that work stress has a negative impact on their personal lives. Managers of a large restaurant chain wonder whether this claim is valid for their employees. So they took a random sample of 100 employees, and 68 of them answered yes when asked the question, does work stress have a negative impact on your personal life? Okay, and the question is this good reason to think that the proportion of all employees in this chain who would say yes differs from 0.75? Okay, so we've got a couple of things going on in this scenario here, right, and a couple of important pieces of information to pull out. So 75% is our claim, our population proportion. Okay, we have N of 100, and then we're going to use the 68 to calculate our p hat value, right? And then the key thing here that's telling us that this is a two-sided hypothesis test is this word right here, differs. Okay, so the managers of this restaurant chain don't really want to know if their employees' stress level is actually less than the national average or more than the national average. They just want to know, is it different? Okay, so that is the key word right there that tells me that I'm dealing with a two-sided or a two-tailed test. Okay, there are very few differences, okay, between two-tailed versus one-tailed tests, and I'm going to point those out to you as we go here. Okay, so let's go through our steps, right? Our phantoms procedure for hypothesis tests. So my parameter here, we are examining the true proportion of employees who feel work stress negatively impacts their lives. Okay, and that is P, right? The second letter here is H, which stands for hypotheses. This is the first place where you're going to have a slightly different, you're going to write your hypotheses slightly differently than you do with one-sided or one-tailed tests. So my null hypothesis is written the same way. Okay, so my null hypothesis is that my population parameter, my population proportion is 0.75. Okay, now my alternative hypothesis is a little bit different. Okay, so because I don't care if it's less or greater, right, rather than putting a less than symbol or a greater than symbol here, I'm going to put a not equal to symbol. So all I really care about is that whether or not my proportion is not equal to 0.75. Okay, so that's the first like major difference, okay, between one and two-sided, is that not equal to symbol right there. Okay, all right, let's move on to the assumptions. So for random sample, we're good there. It was stated in the problem. Okay, population is larger than 10 times the sample, so that's my 10% condition. So I'm going to do 10 times my sample size, which is 100, so that's 1,000. And they said that this was a large chain, so we can definitely say that 1,000 is less than the total number of this chain's restaurant employees. Okay. And then my large enough sample is my number of successes and my number of failures both have to be greater than or equal to 10. So NP is 100 times 0.75, okay, which is 75. It's definitely greater than or equal to 10. Okay, and then N times 1 minus P is 100 times 1 minus 0.75 is 0.25. That's 25, which is also greater than or equal to 10. All right, so I'm golden there. All of my assumptions work out. Okay. N is my next step, which is to name the test. Now, even though this is a two-sided or two-tailed test, I still only took one sample. So this is still a one proportion z-test. Okay, and then we also need to make sure that we set our alpha value here. They did not give us one, so my default, if they do not give me a significance level, is 0.05. So that's what I'm going to use. Okay. All right. Test statistic is also calculated the exact same way. Okay. So I need my p hat. So p hat was 68 out of 100. Right, and that's 0.68. Okay, my population proportion claim is 0.75. My sample size is 100. And then I'm going to calculate my standard deviation, which is the square root of 0.75 times 1 minus 0.75 is 0.25, divided by n, which is 100. So my standard deviation is 0.0433. Okay. So then I'm calculating my test statistic, which is z. So I'm doing my data point, which is p hat, so 0.68, minus my population claim here, 0.75, divided by my standard deviation, which was 0.0433. So I'm just going to plug all of that into my calculator, and I get that z is negative 1.62. Okay. All right. Next step is to obtain our p-value. So what we are calculating is the probability that p hat is not equal to 0.68. Okay, because we're dealing with a not equal to here, that's the same as 2 times the probability that p hat is less than 0.68. Okay, so that's the same as 2 times the probability that z is less than negative 1.62. Okay, so now I'm going to pause for a second because some of you may be thinking, or maybe you don't remember, why did I multiply by 2? Where did that 2 come from? Okay, so if you recall, right, we're dealing with a two-tailed test, right? And it's called that because you literally are shading in the two tails, right? So I'm just saying it needs to be different than 0.68. So it could be down here or could be up here, right? Or sorry, different than 0.75, right? So I'm dealing with both tails. But remember that the areas here and here are equal. So equal areas. Okay, so if you find the area to the left, then you can just multiply it by 2, right? So the probability to the left, the area under the curve to the left, right? Multiply it by 2, and then you'll get the total area in both tails, right? Now, the reason that I went with the less than probability here rather than the greater than probability is because I looked at my z value and it was negative, right? So it's going to be a little easier for me to find the probability that z is less than a negative, right? Because that would put me here, right, in this general area, okay? If you do a problem where your z value is positive, the best thing to do is find the greater than probability and multiply that greater than probability by 2. Okay, so I'm choosing the less than because my z value is negative, or you can think of it as my p hat value is less than p. Right, so I'm choosing less than because my p hat value is less than p. Okay, so you should choose the greater than if p hat is greater than p, right? Just to make your life a little bit easier. Regardless, you're still going to multiply by 2, right? That part doesn't change. Okay, so I did this part by plugging this into my calculator, right? Like I didn't want to have to use my z table for this. So this is 2 times this probability that z is less than negative 1.62 is 0.0548. Okay, so if I multiply that value by 2, I get 0.1052, which is definitely greater than my alpha value, right? So now I've gotten to step 7, right? The M, which is to make a decision. Right? So I have my p-value, which is 0.1052, and that's definitely greater than alpha. So you're going to fail to reject the null. Okay, and then finally, I have my conclusion and context. So this is going to stay the same as your one-tailed test. So we would say because the p-value is greater than alpha, we fail to reject the null. And then we would say we don't have enough evidence to support the alternative hypothesis, HA, which states that the true proportion of employees who feel stress has a negative effect on their personal lives is not equal to 0.75 for this chain. Okay. And I'm pulling that directly from the parameter step, right? So part of the reason that I make you write the parameter step is so that you can have the wording to then use in your conclusion and context here. Okay, so if we go back and we look at our entire procedure, okay, the only place where differences occur, so I'm going to put a little key for you here. So if I've circled it in blue, it's different from a one-tailed test. Okay, so we have a difference here, right? It's this, the not equal to symbol, okay? And then we have a difference here. Whoop. Okay, we have a difference here. Those are the only 2 differences. Other than that, it's exactly the same as a one-sided test, okay? All right, so what I would love for you all to do is scroll back up to page 19, okay? And I want you to try this problem for that's talking about teens and cigarette smoking, okay? So again, this is a 2-sided test, so you are going to end up using, right, these couple little differences that show up, but other than that, the process is the same, okay? So go ahead and pause the video, give this a try, and then check back with me to see how you did. All right, folks, so go ahead and check your answers against mine. So in this problem, we are talking about at a large urban high school, there's this student that wants to know if the proportion of students who've never smoked is the same as the national result. Okay, so we have a sample size of 150, and out of those 150, 90% say that they've never, or 90 of them say that they've never smoked a cigarette, and the national proportion is 50% of high schoolers have never smoked a cigarette. So my parameter is the true proportion of students at this high school who have never smoked a cigarette. So that's P. Okay? My hypotheses here are, my null is that P is equal to 0.5, and my alternative hypothesis is that P is not equal to 0.5. Okay, because remember, we are just trying to figure out if this result is true at this high school. Whether it's less or greater, I don't care, right? I'm checking to see if it's different. Okay, for my assumptions, I definitely have a random sample. It was stated in the problem. For my 10% condition, I have 10 times 150. That's 1,500, and that's reasonable to say that that's less than the total population of this high school students, right? Because in the problem it says this is a large urban school. Okay, and then my large enough sample is NP and N times 1 minus P. Those are both 75, which are both greater than or equal to 10, so we're golden there. Okay. Naming my test, even though we're dealing with a two-tailed test, this is still a one proportion Z test because I only took one sample. They did not give me an alpha value here, no significance level given, so I'm going to choose 0.05. Okay, and now that I've set everything up, I'm going to go into the actual math part of this. So P hat is 90 out of 150. That's his sample value. So 0.6 is my sample proportion. My claim, right, the claim of my population proportion is 0.5, N is 150. I'm plugging all that information into the standard deviation equation, remembering to use the population proportion rather than the sample proportion in my standard deviation calculation. So I got 0.0408 for my standard deviation. Then I'm going to use that to calculate my test statistic, my Z-score. So I'm doing my sample value, 0.6, minus my parameter, 0.5, divided by the standard deviation, 0.0408. And when I did all of that math, I got that Z was equal to 2.45. Okay. Now, up to this point, the only difference from the one-tailed tests that you've done was in the hypotheses. Okay. Once you get to this O step, you also are going to have a slight difference, which is we are finding the probability that P hat is not equal to 0.6. That's 2 times the probability that Z is greater than 0.245. Or you could write it as 2 times the probability that Z is less than negative 2.45, right? It's either greater than the positive Z value or less than the negative one, right? Because we're dealing with 2 tails here. That's why you're multiplying by 2. And the normal distribution is symmetric, right? Now, everything that I wrote out here, all the probability notation, you do not necessarily have to write all of that out, right? You probably should write this, okay, and then you could skip to just writing this, the 2 times, and then you have this, but it's a good idea to write one or the other of these guys. Usually a good idea if you have time, okay? So once I did all of that math, right, I got the probability, the 0.0071 from my calculator. I used norm CDF, but you could use the Z table also. You would get a very, very similar result. So my final p-value is 0.0142. So this is my p-value. Okay, so that's how likely this statistic would be, the 0.6, how likely that value is to occur if we're assuming that at this school, the proportion of students who don't smoke is actually equal to 0.5, right? Because that p-value is so low, that's making me think that the assumption, our underlying assumption in our null hypothesis is false, right? And that's what happens at that the M step here, where we make a decision. So because my p-value is less than alpha, the alpha that I set, the significance level, I'm going to reject my null. And then finally, I have to state my conclusion in context. So here's how this goes. I said because the p-value is less than alpha, we reject the null hypothesis. We do have enough evidence to support the alternative hypothesis, HA, which states that the true proportion of students who have never smoked at this high school, so that's your parameter that you wrote up here, okay, is not equal to 0.5. We don't know if it's less than 0.5. We don't know that it's greater than 0.5. We only know that it's not equal to 0.5. All right? Okay, folks, so that is it for this video. I'm hoping after seeing 4 different hypothesis tests done, you're starting to get a feel for the process, right, and how to set these problems up in order to hit every mark that you need in order to fully answer the question and get all of the points on the AP test. I promise, even if after watching all of this, you're like, I still feel like there's a couple steps where I'm not exactly sure what I'm doing, we are going to do this more throughout this unit when we get to a difference of proportions, right? So you'll get to repeat all of this. I promise you'll be doing so many hypothesis tests. By the time we get to the end of this unit, you might be sick of them. But I promise you'll have the muscle memory at that point to perform one of these tests and perform it well. All right, so that is it, everybody. And that's the last video in this section. So I'll see you in the next video in the next section. Bye, everybody.